All right, class. So yesterday what we did is we solved inverse and direct variation questions. Today we're going to be going over combination variations. It's going to be a little bit of like joint, what joint looks like, your joint variation, and combination variation. Nothing too crazy. Just a reminder that you have a quiz on April 22nd, so it is this coming Thursday. And then we have a Unit 9 exam on April 27th, along with our final exam being May 12th. Any questions or concerns over these dates, send me a message. For our do now, what I want you guys to do is identify any holes, vertical asymptotes, and horizontal asymptotes. What I'd like for you guys to do is go ahead and try doing this on your own. You can pause the video, and then when you're ready to check your answer, go ahead and continue watching. So pause right now, and now let's work on it. So when we're doing this, we're going to go ahead and identify that we have a trinomial here in the numerator. Like I've been saying, most trinomials that we've been covering, we can break up into two binomials. So in order to get the factors of x squared, that would be x times x. I want two numbers added that give me 4, but multiplied also give me 4. That would be a positive 2 and a positive 2. All right. 2 plus 2 is 4. 2 times 2 is 4. In my denominator, I have x squared plus x minus 2. So I'm going to break that down into two factors. My factors of x squared are x and x. I want two numbers added or subtracted to give me 1, but multiplied give me negative 2. Well, that would be a positive 2 and a negative 1. 2 minus 1 is 1. 2 times negative 1 is negative 2. So now that I've got my factors, what I want to do is I want to identify what can I simplify out. So x plus 2 and x plus 2 are my removable factors. As soon as we remove them, you need to set them equal to x. So we're going to say x plus 2 equals, you're going to set it equal to 0. So sorry, guys, so sorry. We're going to set it equal to 0. When we do that, we're going to get x equals negative 2, and this is where we have identified a hole. Okay. For our vertical asymptote, so what we want to do here is we want to make sure that we write our factored form here. We would get x plus 2 over x minus 1. And we want to take our denominator here, and we're going to set that guy equal to 0 as well. And we get that x equals 1. And this is the equation for our vertical asymptote. Okay. And lastly, for our horizontal asymptote, you'll recall that there was some rules around the degrees of the numerator and the degree of the denominator. Because these two degrees match, what we have to do is we have to take the coefficient of the numerator, which is 1, okay, and we are going to divide that by the coefficient of the denominator, which is also 1. Okay, and so we get that y equals 1, which is our horizontal asymptote. Cool. So give that a shot. Again, we'll be practicing these skills until your exam. Let's go ahead and move on to our new material. So yesterday we talked about direct variation and inverse variation. Just to recall, direct variation was y equals kx, and inverse variation was y equals k over x. Joint variation, like it says here, y varies jointly, okay, as x and z. So we would see that as y equals x times z, and we do have our k. We can't forget k. So like for number 3 here that we have, we would say that this would be joint variation. Okay, and our k value, our constant of variation, would be a 5. Okay, this lines up to what we did yesterday. Okay. Let's go ahead and move on to our next scenario. What about combination variation? So combination variation is a relationship that contains both direct and inverse variation. So here, like 16 says, y varies directly as x and inversely as z. So we would say this would be y equals k, right? K is always in the numerator. And it says directly as x. So directly would be straight across. And inversely was z. So z is in this denominator here. And this is how we would identify our combination variation. Okay, go ahead and copy that down, put these in your notes. Pause the video wherever necessary. Let's go ahead and work on a practice problem together. So it says A varies directly as B. Okay, so we start off with A, right? So we're going to say A varies directly. So we have K and B. And inversely was C. So C is going to be here in the denominator, right? Directly is B, inversely is C. It says if A is equal to 16, so I have A equals 16, B is 12, let's write that down, and C is 6, okay? Find A when B, so I'm looking for another scenario, when B is 28 and C is 4. So what they didn't give us is they didn't give us K. They didn't give us our constant of variation. So as typical, that's what we've been solving for this past couple of days here. So we're going to start plugging in these values. So we're going to say 16, right, is equal to K times 12 over 6. So what we can do here is we can start simplifying this out. Well, I already know that 12 and 6, I can reduce that. I'd have 16 equals 2K, right? 12 divided by 6 is 2. And then I can divide both sides here by 2 to simplify that out, and I get that K is equal to 8. I'm going to box this because it's important. And so then our equation itself would be A equals 8B over C. And we want to start plugging in these values, and we're looking for A. So what we're going to do is we're going to say A equals, well, A is equal to 8 times B, which is 28. All of that over 4. Okay, so then we'll get B equals, okay, go ahead and take the time. I'm so sorry, I put B equals, and it is not B. We're still solving for A. Okay, oops. A equals, so let's go ahead and let's take the time to work that math out there. We want to do 8 times 28, so we would get 224 over 4. And when we reduce that out, well, we get that A is equal to 56. Okay. Go ahead and finish copying that down. If at any time, guys, you already know the routine. If you have any questions or concerns, send me a message on Teams. I'm more than happy to help you guys out. Let's go ahead and move on. So let's look at this problem here. Now this is kind of like a little step in here. We've actually seen this problem already. It says the time it takes to fill a water tank varies inversely. So we're just following the steps. So real quick, we know that it's inversely with the water rate of a hose. At 8 gallons per minute, a hose can fill a tank in 45 minutes. How long will it take? Okay, fill in the tank at 15 gallons per minute. Now, we've already seen these before. We have already seen this question. I just kind of want to take the steps into identifying what's happening here. So it says the time it takes. So time here is my y as it varies inversely. So inversely would be y equals k over x. Okay. With a water rate. So that water rate is going to be my x value. So we're going to say y equals k over x, where y is equal to my time, which in this case would be 45 minutes, and x is my rate, and my rate here is 8 gallons per minute. So when I start setting this up, I'm going to say 45 equals k over 8. And I want to solve for k. Okay? So to solve for k, what we're going to do is we're going to multiply both sides by 8. These simplify out, and I get that k equals, well, 8 times 45 would be 360. Box this because it's important. Now we take that 360 and we're going to put it back in here. We're going to say y equals 360 over x. And they want to know, okay, how long will it take? So they want to know the time when we're at 15 gallons per minute. So we're going to do this when our rate, when x is equal to 15. So we're going to take this and we're going to substitute this in. So we're going to say y equals 360 over 15. Okay, so you're going to do 360 divided by 15, and that would be at 24 minutes, or 24 gallons per minute, right? I'm sorry, 24 minutes total. And this makes sense, right? We're going faster. We went from a rate of 8 to a rate of 15, and so now it takes 24 minutes. Okay, again, we've already done this problem. I just want to go over like the reading techniques. So now let's go into where we have some combinations. So here for the combinations, it says the volume of a pyramid varies jointly, okay, with the height and the area of its base. Okay, so let's break this down. So jointly, everything is being like direct variation across. So it says the volume is varying jointly with the height and the area of the base. So that would be our base squared, right? Okay, don't forget that the base of a pyramid is the sides, right? The pyramid with a height of 16 and a base area of 78. Okay, so that's important to know. So the height here is 16, and the base area, okay, so that base squared is already 78. Okay, so that's nice. They gave that to us. Has a volume of 416 cubic feet. So that means that we still have this k value, right? That's our constant of variation that we want to make sure that we have. Okay. And so we want to figure all this out here. There is some kind of constant of variation. And so we're going to take all this information. And they're telling us here that the volume itself is 416. So when we're doing this, we're going to set this up as 416 equals our k value times 16 times 78. Okay. And so when we start simplifying this out, we'll get 416 is equal to k times 16 times 78 is 1,248. And what we want to do is we want to divide both sides by that 1,248. Okay, so 416 divided by 1,248 would give us a k value of 1/3, approximately 0.333, and so on. Okay. Now, they want to know if the pyramid has a base of, so our new base squared area is 102, and a volume of 238, then what is the height? We're looking for that height there, okay? So let's go ahead and do that. We're going to look for that height. And to get that height, we're going to take the same equation, V equals KH, and that little base squared. We're going to start substituting our values in. We know that our volume is 238 equals K, which is 1/3. We'll leave it as 1/3 as that's the most accurate number. We're looking for H, and we know our base squared was 102. Okay, so just to make things a little easier on us, I'm going to divide everything by 102 first. Okay, so we're going to divide everything by 102. So 238 divided by 102, okay, gives us 2.333, right? And it's actually 2 1/3 equals, right, these simplify out, 1/3 times H. So to get rid of this 1/3, what we're going to do is we're going to multiply both sides by 3. Simplifies out. So I get H is 2.33333, or 2 1/3 times 3 would give us a height of 7. And this makes sense. Our original volume was 416 with a height of 16, or our new volume was 238, so it's a lot smaller. And so our height should be smaller as well. Okay, so this is all jointly. And we have to look at these variables and remember our certain values. And what's nice about this is this kind of goes with our equation for the volume of a pyramid. Okay, typically you're given though that K is already 1/3, and that is the constant of variation. Okay, let's go ahead and move on. So we have an independent practice problem, and I want to work with you guys on this. Help set you guys up for success. It says the wind force F, so we're going to say the wind force F varies jointly as the area of A, so that's going to be equals K, that's the area of A on a sail, and the square. Okay, so we're going to say the area A and the square of the wind speed W. Wind speed squared. This is where it's going to get a little interesting here, because they're going to give us the area and they're going to give us the wind speed, but we're going to have to square this wind speed. So we're going to be mixing some skills here. Okay. It says the force on a sail with the area, okay, on an area. So they're saying this, that the area, they're telling us that the area is 500 feet squared. Okay. And they're telling us that the force itself is 64.8 when the wind speed is 18 miles per hour. They say, what would the force on the sail with an area of 250 feet squared with a speed of 35? Okay, so the area is actually getting smaller, and the speed is picking up. So what we got to solve for is our K value. So what we're going to do here, and I'll help get you guys started with K. We know that we have 64.8 equals K times our area, which they already gave us was 500. And they said that our wind speed was 18 squared. We have to respect that squared. Okay? And so what you want to do here is you want to solve for K now. So as far as the steps are concerned, make sure that you 18 squared, isolate K. So what is your K value? Okay? Once you have your K, you're going to want to rework this equation with the new parameters that they're given. Okay, they want to know what the force is, okay, when the area is 250 and the speed, the wind speed, is 35. So you're going to be looking for the force when you know what K is, times 250 times 35 squared. So you got to get K in order to get F. All right? Again, if you have any questions, send me a message. I'll be more than happy to help you out. The next question, okay, says the volume V of a gas varies directly as the temperature T and inversely as the pressure P. All right, so we have volume is equal to, okay, the direct variation, so we have K of T over the pressure P. It says at a temperature of 200, so we'll say temperature equals 200, and a pressure of 500, the volume is 240. Okay, so we're going to use all this to find K, and then they'll give us new parameters. So let's go ahead and set up our equation to solve for K. So we're going to say 240 equals K times 200 over 500. You want to get what K is. Once you know what K is, you're going to want to follow this for the new parameters. It says to find the volume, so volume is what we're looking for, when the temperature is 275 and the pressure is 400. So your equation would be V equals, well, K is what we're looking for, times 275, right, all over 400. So in order to get the new volume, you got to get the K first. And moving on, lastly, you have your exit ticket problem. I am not going to help with this one at all. I want you guys to annotate, identify the equation, solve for K, and then use the new parameters. I will, however, help you if you have any questions. So if you have any questions, send me a message, and I'll be more than happy to help you guys out. All this material will be on the next quiz. It will be on the next exam, so you want to make sure that you spend all the time needed for this. Have a great day, guys, and we'll see you all tomorrow. Bye.